Hi guys, Ashwin here. This is episode 7, part 2 of kiosk implementation and how we are going to implement kiosk. To make sure that we are going to create a module which is related to auction. It's much related to an auction module. It's an auction module basically, but it's going to be very simple, where only two parties involved and make a bid, and whoever is making the highest bid is going to take the NFT out. So this pretty much looks very simple, but when we get to see the implementation and how it works under the hood, it looks a bit much more complicated. But yeah, I'll try to make it very much simple and to understand kiosk and how we can use it in real time implementation. Yeah, let's get started. So let's get started with how this module is implemented. And first of all, we have discussed about kiosk extension in the previous video, right? And I want to get a go on that first of all, and later on how this exact module is designed. First of all, I'll talk about that because when we will be going line by line only, the implementation that I did, okay? And I'll tell why I did it in this fashion, and why not in other way. So we will discuss it in the Excalibur here, and then we will move on to there, so that you will get a better understanding of what we are going to implement, right? So when we discuss about kiosk, it's a very much centric approach, right? Whoever um, whoever is holding the kiosk, right? So whoever is creating the kiosk has the whole control over the kiosk and its assets inside the kiosk, right? So when we think about having a better decentralized control, where you just try to put in different assets into a single kiosk, let's take up an example. Let's say this is person one, and he creates a kiosk, and person 2 say wants to he is having some assets, okay? He is a creator. What is the exact point here is, when he is having some NFTs, so NFTs, he needs to put these NFTs into this kiosk, right? It's kind of a collection. So when he tries to put in this exact NFTs into this kiosk, he can only do this via kiosk extension, which we have discussed in the previous episode. What is kiosk extension? So when we discuss again what is kiosk extension, just the very overview, we can make sure that this exact owner authorities, whatever this owner authorities is given to this exact kiosk, can be given some controls, can be given. So whatever controls that the kiosk owner wants to give to P2 can be done via this kiosk extension. That is the point here. So I can set some permissions to this exact extension. So this exact extension can be installed to this kiosk, and that permissions can be allocated to this extension. So these persons can be can make sure that the permissions allowed by the P1 to the P2 can be used by the P2. So for instance, like take, place, and store, sorry, it's not store, log, some these kind of operations can be done by the person 2 itself. So this is the thing that I need to put up here. So okay, using kiosk extension you can do that, but what is the drawback here is, when we talk about technically, when we implement in the module, you will see it in action, but I will discuss why it is not feasible in real time. So let's say I am doing this fashion. I am just putting the assets inside this kiosk using place. Okay, I am placing the assets inside the kiosk of this belongs to this guy. P1 is the owner of this kiosk, okay? So I am placing the assets inside this kiosk, but what exactly I need is, I also need to make sure that person 3 comes into picture. person 3 comes into picture and get some say this is the NFT of P2. This is the exact NFT of P2. This exact P3 should have some yeah, he can purchase it. But what is the point here is, so when he tries to purchase this NFT P2, what happens here is he need to, this exact P2 is the owner of this asset, right? So that should be something like transfer policy should be accepted, or there would be a request made. Okay, there would be a request made by this exact P3 saying that I need to purchase this NFT with the price that you have mentioned. So this is a request. So this exact request will be need to accepted by this exact P2 with some say TP cap, and yeah, this TP cap will be given by this P2. Or what we can do is, so this is something like mostly authorization caps are owned object, right? So owned object, it's going to be an owned object. um, it's going to be an owned object, but we can make sure that you make this TP cap as a secure shared object using dynamic object field. But yeah, we can just get to the point that you can make it as a shared object. You don't need the involvement of P2 here to accept the request made by the P3, right? So you can do that. So that can be done with dynamic object field concept. Okay, so what I'm getting to now is, so when you can do that, so what is the drawback here? That's what you can question me, right? So what would be the drawback is, so let's say, so what would be the problem that I was coming to mention is, so it is in the initial state of creating the module itself. Say I'm just let me just come here. So let me say, as we know it, we are talking about in the ending stage in the sense, when P3 person 3 needs the NFT, he keeps a request and it should be accepted by a transfer policy cap. And the transfer policy cap basically says that transfer policy applied on that exact NFT transfer request that you are making is valid. The rules are applicable, and you make sure that you apply, you are just undergoing those rules. So I'm just agreeing your request. That's what this exact call says. But this can be done using DOF, dynamic object field, because it shouldn't be the case that you need to make sure this transfer policy cap is only a owned object, right? You can make it as a shared object, and you can make sure that it is secure as well. That is the main thing. You there is no assuming that whatever it is a shared object, it is not secure. That shouldn't be the case in our move modules. Okay, so we can make it secure. So but there are some criteria, right? So let's say if that object doesn't have the ability store, then you can't make it as a shared object, protected shared object. So that is impossible. So why I'm talking about this is, so when we talk about using this fashion, kiosk extension fashion, and coming till this end of the process, we didn't make sure that we create the transfer policy, right? Transfer policy new. Let me just undo this. So transfer policy new. I need to pass in the kiosk owner cap. So in our case, P2 is the kiosk owner. Okay, sorry, not P2. P1 is going to be the kiosk owner cap. So kiosk, this P1 is going to be the kiosk owner cap. So what is the problem here? You can ask me, because it's the same module. Because what is the problem here is, you can't have a function pointed with P2. Okay, P2 is going to be the interactor with this exact function, but you can't make sure that you call you can say that T1 is going to send the kiosk owner cap, right, to this exact function to make sure that both are calling this function. It can't be done. So another way of doing this is you can make sure that this kiosk owner cap is dynamic object field. But when you do that, can you even do that? You can't do that, because so when we create the kiosk, what happens is you get the kiosk owner cap in return, but it is of with ability key. So when we think about having key object, so it can't be stored as a shared object, using dynamic object field. So you got to a point where you can't do this, right? So now what we can do is, this is where another approach comes in, where you this is something inevitable now. You make sure that you design your module, say, like person one is comes in, he is a creator, NFT creator. He comes in and call some function, and okay, let me undo this. Still I have some problem. He calls some function, and he makes sure that he creates a kiosk for himself, right? So he creates a kiosk for himself, so that there is no problem with he accessing the multiple modules, like multiple functions inside the module that we are going to create. Because when he creates the kiosk, he is going to get the kiosk owner cap, and also we are going to make sure that we are making this kiosk as a public shared object, so multiple people can uh, can see that, or yeah, it can be done. So kiosk should be a shared object, right? So and owner cap should be an owned object. It should be, because you can't make it as a shared object because it doesn't have store ability. So now this is satisfied. How this is satisfied is, now what you can do is, since you are the NFT creator and you have your own kiosk and a kiosk owner cap, you can make sure that this exact kiosk itself can have multiple NFTs, and we can make sure that you have the whole control over your what you are doing, right? So when we think about now, let's say, when we think about in our auction module, say this is our auction module. So say this is our auction module, and this NFT creator is going to get an kiosk and a kiosk owner cap for himself from our auction module. Okay, function, and he calls it and he gets it. Okay, he gets this first thing. Then later on, what else he is going to do is, he is going to make sure that he is going to list it. Okay, I'm having some problem now. My CPU usage is too high now. So he is going to list it, list this exact NFT. So say, this is the creator that we are talking about. He is having an NFT, and he is going to put this NFT, right? Say, like, this NFT is going to be listed. So list with purchase cap. So we will discuss what is this purchase cap now. So he is going to call this exact function, and he is going to list this NFT, like in his kiosk itself. In his kiosk itself, he is going to list this NFT. Okay, so it is for sale now. So what is the thing is, so what is the point that I'm coming to make is, why we are using list with purchase cap and not a normal list. No, why not a normal list, and why list with purchase cap? That is something we need to discuss, right? So why not list, and why list with purchase cap. In our exact auction model that we are talking about, list with list with purchase cap is necessary and list is not necessary, uh, because list basically says you are going to put your NFT for sale. So whatever asset that is coming into the kiosk as with the list function being called, that exact NFT is for sale. So it's like, you know multiple entities P1, P2, P3 can fight for a single NFT, right? So it is like, it is not about talking about racing condition here. What we are talking about here is, that is not the requirement that we are building, right? So when we talk regards to the model that we are building now, so it's just involvement of, who is going to win is going to take it up. So winning the auction and he is going to take it up, right? So listed purchase cap, what it does is it's going to return a purchase cap, like, give me a second. So it's going to return me an purchase cap, and I can make sure that whoever wins the bid can have this purchase cap, and using this purchase cap he can claim the NFT finally. Okay, so this is the module that we are talking about, and we will see it in action just within few minutes. And one another thing that I need to mention is, we also need to make sure that in EVM also we follow the same standard, where you have your NFT contract, you mint your NFT, then you come back to a platform and you do this auction stuffs, everything. You have the same thing here, but with some slight different complexity added up, and we will just see it in straight to the code base itself. That would be a lot better actually. Yeah, let's jump into the code base then. So since we just now saw the architectural overview and explanation of how our model is going to look, so it would be better to start with the actual implementation that I have designed. So these are some things that we have already discussed in the previous start of the video. So why I have kept the constant as auction duration as 24 hours is just for simplicity purpose. So two bidders is going to bid and fight for an NFT, and who is making the highest bid within 24 hours. When the second bid comes in, I just call I make the boolean value as true, and complete the auction over there itself, and calculate the winner based on the highest bid. So it's a simple logic. But when we think about in the fashion of how object-based model works, then when we see it as a very new model, then it's quite complicated. But yeah, it's pretty much easy. So let's get going. So this is a shared object that I'll be defining for keeping track of the active auctions being conducted in our exact module. Okay, so I'm just, yeah, this is something you can understand, right? So it is having a key ability, and ID I'm defining it with it should be an unique ID, and active auctions, and it should be of type U64. So next up we have the struct auction data, and which is going to have the ability key and store, and these are some things we will discuss. Okay, so we will discuss in the below section when we call this exact struct. Okay, so protected transfer policy, I'll just tell when we are using it, and we'll come back to this. And these are the event emissions are not pretty much important right now, but I've just used for transparency now. So but yeah, we'll be seeing when we call those events as well. So let's get to the initialization function. So we are passing the one-time witness auction. We know the rules of how we are defining one-time witness, right? So that exact one-time witness should be of full in caps letter, and it should be in the same naming as the module. Okay, and we pass in the transaction context, and first of all we need the publisher. In current module we are not using this publisher, but for namesake I've just defined it to show you how this exact publisher object is being claimed. So to exactly it is to be said, to claim the publisher object, we need to pass in the one-time witness and the transaction context, and we are claiming the publisher. And with this exact publisher, we can make sure that whatever types that comes out of the publisher is with we are just as we can have asset statements say this exact NFT type belongs to this exact package or module. You can make sure that you use this publisher object to do those things we discussed in the previous video. So that is one thing, and we are defining the auction house structure. So as I've said above, so I'm just making it as a shared object, and I am transferring the publisher object to the deployer itself. So for in this case it is no use, but yeah, I'm just showing how it works. So since we didn't see it in the implementation, so next up what we are going to do is, so this is the setup auction function. What I'm pretty much doing here is, so we need to have this as a separate in my regards, or how it should look like in the production. What I am thinking is, in my opinion, it should be as a separate module where you have this setup for auction function being called. Okay, so why I am telling this is, so when we are doing this, this is a user, from the user point of view, you are going to call this module. So when we call this user in this module, so you are going to pass in the publisher object and the transaction context. Why I am asking you to pass that publisher object is, with this only you are going to create a transfer policy cap and the transfer policy, right? So you need you need this publisher object. So that is the rule that transfer policy module is defining. So when we are calling this, we need to pass in the publisher and we need to pass in the CTX. It is necessary because you are proving the type of whatever you are going to approve in the final way, like so using this exact, so in the final end, so someone is going to trade your asset. So when they are trading your asset, you can make sure that in the contract we need to make sure that that exact tradable asset type belongs to this exact publisher. Publisher in the sense belongs to the exact package. So publisher, if you see in the fields, you can make sure that it has the package and the module, whatever type that it has, package or module I'm talking. So you are defining the transfer policy, and you are just initializing here and to get the transfer policy and transfer policy cap. So the policy cap should be mostly, when we talk about caps, it should be an owned object. But when this transfer policy cap is as type store and key, then you can make sure that you can have it as a shared object, protected shared object, and use the transfer policy cap to agree on request for the assets that is being transferred over between entities. So this is the transfer policy, and policy cap, we are wrapping it with around in a protected treasury cap. So let me just jump here. So as you can see, this is the skeleton structure. So ID, transfer policy, and policy cap. So I'll just jump back. So I'm defining it, and I'm sharing it as I'm making it as a shared object, so that I can finally use this transfer policy cap to agree on request. So we will come to that part as well. So here comes the another interesting part where we discussed not interesting, but yeah when we discuss about move, it is quite interesting. So because in EVM we don't have this quite a bit complexity in EVM point of view. So when we talk about creating kiosk and listing NFTs, so why we need to create a kiosk and list the NFT in a single atomic transaction, we will discuss here itself. So what exactly here we are doing is, we are passing the auction house, which is the object that we have defined previously in the init function, and the user NFT. So how it works is, so you will be having a separate NFT module. So user is going to have separate NFT module, and he is going to create a NFT, and that NFT is going to be passed as an input to this exact function. So it is of type generic, and starting price is that the user says that my NFT has the starting price of this much amount, say 10 Sui, something like that. And clock object, it's actually a system object you are passing in, so you can keep track of the timestamps of which exact time the transaction is being pulled off, right? So you can use this exact clock object for that purpose. And transaction context we have discussed previously. Now this exact function is going to return a kiosk owner cap and an ID. So what is type ID? So we discussed about UID, unique ID. So what exactly it is saying is, so you create some unique ID, or unique object, and you have a field unique ID, right? When you need, it is something an existing object already, so you are passing that to another object. Say I'm passing that exact ID, existing unique ID, to your field ID as just a unique ID. So I think you get the point. So it is something existing, so you're passing in as type ID. So that is something. So this exact function is going to return owner cap and the ID. Why we will be discussing, and why it is an atomic transaction also we will be discussing. So user ctx.sender, and create new kiosk for user. So we are just initializing the kiosk, and when we initialize the kiosk, we basically get the kiosk owner cap. So as you can see, it has type yeah, you can see, right, kiosk owner cap and the kiosk. You get two of the things back, and you make the kiosk as a shared object and kiosk owner cap as a owned object. You can only make it as a owned object because it can't be made it can't be made as shared object. So that is the thing. uh, Kiosk ID is something you derive from the object you pass in, like the kiosk you pass in, and you get the ID, and you mark the kiosk ID variable as the kiosk that you are creating here. So placing the NFT in user's kiosk. So what exactly here we are doing is, the NFT that you are passing in, you are passing that NFT into the kiosk here. Here is the exact part that we are doing it. Kiosk.place and the capability object. So since kiosk owner itself is like, who is calling this function is going to be the kiosk owner. He holds the kiosk owner cap, and then also to be very specific here, you also pass the user NFT, which is he is owning. So this is the point that we discussed in the escalator part. So if not, I am not a owner, to say I am just a person too who is putting my asset into a kiosk owned by P1, then I don't have the access to kiosk owner cap to place the asset over there. But you can overcome with a kiosk extension. But when you overcome with the kiosk extension, but you get caught here. So you need the publisher object and CTX to initialize the transfer policy, to get the transfer policy and transfer policy cap. So that's what we discussed in the escalator part. So we are placing the NFT. Then we are create exclusive listing with purchase cap. Why we need this exclusive listing is, as we discussed previously, it is an auction module. So only one specific entity is going to receive my NFT, not like multiple guys just suddenly it can be misbehaved, right? Like say within the auction module, I am making sure that it is just getting placed, or it's just getting listed, not list with purchase cap. I'm not calling list with purchase cap function, and I'm calling list function. Then what happens is then P3, that is like P1 is making the list. Okay, I'm being the owner, I'm making it, and P2 and P3 can make multiple bits out of the module itself for that exact asset. So that's how kiosk works, right? So what I can do is, even though you can do something like that, but you can make sure that that can be purchased only with a guy, only with the guy, only for with the guy who is having the purchase cap. So that's what I'm coming to tell. So when you call this function, you get back a purchase cap. So it returns a purchase cap of from the kiosk module, and which is of type generic, and you pass in these set of arguments inside. So we have no arguments in the sense like we are passing in the parameters. So capability, item ID, minimum price, and CTX. You pass in and you get the purchase cap. Then after you get the purchase cap, you use that purchase cap at the very end. So we'll get to the point very soon. So auction end, I'm just mentioning it as 24 hours, and auction data. So I've told you we'll go back to the exact struct, right, when we discussed about it. So auction data, as you can see, I'm initializing the new unique ID. Item ID is going to be from the NFT itself, as you can see. Seller, and seller is going to be the user, and seller kiosk ID. It's going to be kiosk ID, where what we are storing here. It's the kiosk ID, unique ID. Okay, and starting price is going to be designed by the who's the caller itself. He says that this is my NFT, and I'm selling it this as this base price, right? So current bid is going to be the starting price, and I'm just assigning this starting price variable to this exact field. We'll get to that point why we are having these many fields first of all. And highest bidder, second bidder. So highest bidder is nothing but whoever is making the highest claim, and second bidder, how much price is going to make. So I guess second bidder is going to be something like address, and highest bidder is going to be of also type address. Yeah, we'll see that. And auction end time, and resolved in the sense that exact auction whether it is resolved or not. So that is something. And winning bid amount, how much amount two parties has bidded, and which is going to be the bid winning bid amount. And purchase cap, I am just wrapping it with the auction data struct itself. Yeah, so now since it is an atomic transaction, you need not to worry about. So you also share the auction data with the purchase cap, but this exact purchase cap, when we think about shared object, I told you guys need not to worry about every shared object, right? So think of it something like you when you do some shared object, like when you make a object a share, you make sure that you just need to make sure that it has a very critical code level access. Only with only certain people can access it. So that is what I am talking about. Even if it's a shared object, it doesn't mean like everyone can make calls to that exact shared object. So that's what I'm coming to tell here. So auction ID, and auction ID is from the auction data. Yeah, this one. And auction house and active auctions. I guess you understood, right? So this is the active auction currently in held, and I'm just say if this is the first auction happening in the whole module, then 0 plus 1. So the current active auction would be 1, and sharing the auction data, sharing the kiosk, so that others can make it access it for purchase. So I am just emitting an event. So item listed is the event being emitted. So it is of that event is of type item listed, and auction ID, item ID, seller and seller kiosk ID, starting price, and auction end is the fields that I am emitting as event, and I am returning a capability and auction ID. Then let's get to the main core heart piece of this module. So yeah, later we have the claim only and withdrawal function. So here, as you can see, this is the bid function. So two entities is going to call this exact function. uh, so you pass in the auction data and you pass in the bitcoin, which is of Sui type, because currently I don't I didn't just deploy any custom token and pass that exact type for this exact field. Okay, so clock and transaction context, and this is the main part. Auction data and bitcoin is the main part that we need to notice. So I'm just initializing some variables for further usage. Bid amount. Bid amount is, it's just the value that we are storing, not exactly the coin itself is stored in this exact variable. And you can see here as well, it returns a U64 only. And current time, we are storing it from the timestamp module. So from the timestamp, like from the clock module itself, we are calling the timestamp ms function to get the current time. So we are validating the auction. So whether it is already resolved, whether the auction is already ended, or whether the bid is already insufficient. Say the exact base price is 10 Sui and you make 9 Sui as the bid, then asset throws the error. So previous bid is nothing but this is from the seller, like his actual selling price itself. So the actual selling price is stored in the previous bid currently. So when the first bid is happening, then we replace this exact current bid with the first bidder is who is going to make. Okay, so here what we are doing is, if this exact thing contains some value, then it is true, right? So when it is true, you enter the if control. So if not, you go to the else part. So if there is nothing, like if there is no value here, then you know that there is no current bid happened. So I want voluntarily this exact control to enter the if control. So this exact first bidder is going to enter the if control, and auction data and highest bidder. What I'm doing here is I am filling the bidder address. So the current first bidder address, I am filling it in the highest bidder value, and highest bidder field. Then auction data dot current bid is equal to bid amount. So the amount that we are getting here, I'm storing it as U64, right? So I am just making sure that I am changing it here. So current bid, as you can see, the current bid would be previously the base price that the seller is keeping. So I'm just changing it up here. Then later on, I'm just returning the coin that I'm receiving from the user. But what should I have done is, I should have made a escrow like approach, where you have a struct object and have a balance field and store the coin object internally within the contract, so that whoever is winning the bid, I can take up the money from the balance field itself, instead of asking him again while he claims, right? I could have done that, but yeah, currently I'm just making it very much simple. Again, I'm just returning it. It's not a recommended approach, but yeah, I'm emitting the event here. So bid placed event, auction ID, item ID, bidder, and bid amount, and previous bid. So here in the else part, this is going to be entered only from the second bidder end, because when the first control fails, that is like if it isn't true and if it is false, so there is a current price over there. Current price in the sense the highest bidder value is there. Then what happens is, highest bidder value in the sense the first bidder's address, if it is there, then we go to the else part, where you make sure that you reassign the current highest to the address that second bidder's address is just getting stored here. And here we check whether he is the same bidder or not, first of all, from the bidder variable that we stored initially. Then storing the second bidder address, and with the second bidder field, and current highest is nothing but we are borrowing the auction data dot highest bidder is the highest bidder would be the address itself, the first bidder's address. So this gives the address, and you're storing it in the current highest variable. We'll see why. Okay, so and here itself I am resolving the auction here. So as you can see, but what I should have done is I should have cross compared the two bid requests, and not only two. So if we think about auction, multiple people, multiple entities gets involved, so you need to wait until which is the highest bidder to resolve the exact auction. But I'm just straightly diving into marking it as true because there's only two entities involved, and I need the logic to be very simplified. So determining the winner now. So if the bid amount is greater, and auction data dot current bid. So current bid would be since I have set it up in the if part, if part, that is the if control part. The highest bidder bids amount would be stored in the current bid field, and if it is lesser than the bid amount, then bid amount is kept currently by the second bidder. So second bidder, right? So I am making sure that the second bidder wins. So this is the exact logic that I have defined here. So if the second bidder wins, you return the bidder. Bidder is going to be the second winner's address, and I'm storing it in the winner variable, and else is going to do the opposite. So next up, you are just again returning the coin to the exact bidder who is calling it. But as I have told, it should be an escrow mechanism. But yeah, I've just did it in this fashion to make it simplified. So this is the whole auction part, and yeah, still some part is remaining. So now what I'm going to do is, since I have the winner variable stored, I can make sure winner address is stored. I can make sure that I exactly transfer the purchase cap from the auction data wrapper. I extract the purchase cap and transfer it to the winner address. So auction is resolved, and I have emitted the event here. So now that exact P2 or the winner bidder is going to have the auction that is like the purchase cap, and he is the only guy who is eligible for applying for the claim NFT function and get the NFT. So why here I am making sure that I am passing in the coin to him quite often is for the bidders is because here exactly they are going to use that coin to purchase, not in this exact function. So only. So seller kiosk is a shared object. We are passing it as a mutable reference because we are going to have some mutations happening. You are going to make sure that you take the asset out and transfer it to another guy, right? So to the exact winner. So auction data and purchase cap and payment is going to be of coin types fee and protected treasury cap. So here initially we made sure that we call the I guess it's of some name which we use to create the protected treasury cap. Protected treasury cap and not protected treasury cap. So protected transfer policy and protected transfer policy. So we are passing in the transfer policy to accept the request that is being made. So as you might have noticed in this exact contract, we didn't add any rules to that exact transfer policy. So we should have added some transfer policy if the module that we have designed is quite complex, but it's a very basic version. So yeah, winner uses the purchase cap to buy directly from the seller's kiosk. So seller kiosk, you call the purchase with cap function, and you pass in the purchase cap and Sui coin as a payment, and you construct a request and you get the NFT out of it. So still it is not resolved, right? So whenever the policy itself is used to confirm the request that is being made by the winner, then only that exact amount is also paid, and the exact item itself will just get to the winner, so the NFT. So that's what we are talking about. So the NFT is returned from this exact purchase with cap function, and I am passing into the winner, like I am returning it to the winner. So in JavaScript we just have something like return NFT, return NFT and have colon, but yeah, we can just do it something like in move, you can have it in this fashion. So seller withdraws profits from their kiosk. So since who is going to be the seller is basically me. Me is what I am talking about. Me is I don't have a kiosk and having members to put their assets in. I am just creating their own kiosk for themselves. Whoever the artist comes into this platform or for whatever purpose he is an artist, I am creating a kiosk for himself and making sure that he can withdraw the kiosk from the balance field that is internally in the kiosk itself. Kiosk object itself has a balance field, right? So they can get they can withdraw the balance from that exact object that I am talking now. Yeah, this is the exact model that we have implemented, and hope you guys have got some good amount of knowledge that I know. Yeah, let's see in the next episode. Thank you.